Okay, this lesson is on geometric sequences. Prior to now, we have worked with arithmetic type of sequences and series, so where everything was going to be added or subtracted from each other, and that's what makes it arithmetic. Geometric, though, follows a little bit different pattern. A geometric sequence is a sequence, that's an A sequence, in which, oh my gosh, the ratio of successive terms that's a U is the same. So what that what that means is a sequence in which the ratio of successive terms is the same. The key word is there, or keywords is ratio. So instead of having the same thing being added or subtracted to it, the same thing is going to be multiplied or divided each time. So that's what makes it geometric. So for example, if I did the numbers, if I did example, and I had the sequence like 1, then 3, then 9, then 27. You can clearly see that the same number is not being added every time or subtracted every time. But you could probably guess that going from one term to the next, you're seeing the pattern that things are being multiplied by the same number. This is what makes it geometric. Okay, and that's, and it could be divided by the same number too. So either one makes it geometric. So in arithmetic sequences, we had D, which was a common difference, whereas in geometric we have a common ratio, a ratio between successive terms. And we use the variable r. Okay, so r would represent that common ratio, just like D represented the common difference. That value that is being multiplied or divided between the numbers. So this is going to look very similar to when we did arithmetic sequences. You pretty much just go through the exact same process, just with the different number that's between them. So we want to decide, you always want to, it's not going to tell you that something is arithmetic or geometric, so you have to make sure, now that we know both, determining which one's which. So going through here on a test or a quiz, you might see something like this, and it's not going to tell you if it's arithmetic or geometric. So we have to make sure. When we go through here, obviously the same number's not being added every single time. So we check with if it's being multiplied by the same amount every time. Sometimes it's pretty easy. Like this one is probably pretty easy. You could probably figure this out without doing anything. That it's being multiplied by 3 every single time. But sometimes it's not so easy, and so to figure out what's happening between the two numbers, it is best to understand that to figure out the common ratio, you can divide the second number by the first number to figure out that common ratio too. Notice how 15 divided by 5 is 3, which is the common ratio as well. And 45 divided by 15 and 135 divided by 45 are all a ratio of 3 if you divide them. So that's one way to figure out the ratio as well. Just take the next number and divide it by the first number. And it is consistent. They are all being multiplied by 3. So the R, or common ratio, is 3. Don't know how that happens. So same thing here. It might not be so easy to figure out what's going on between these two numbers. So we want to make sure that it is geometric. It's not the same numbers not being added or subtracted, so it's not arithmetic. So if I divide these numbers, negative 40 divided by 80, it's negative 40 over 80, which is negative 1/2. So let's see if this continues. 20 divided by negative 40 is also negative 1/2. And then negative 10 divided by 20 is also negative 1/2. So it is consistent, and that ratio is going to be negative 1/2. It's being multiplied by negative 1/2 each time. So just like arithmetic sequences, where we had a formula to figure out any term within that sequence, geometric series have a formula as well to figure out any number within that sequence. The formula for a geometric sequence looks similar in that there'll be some similar variables here, but a sub n is a sub 1 times r to the n minus 1 power. So a couple things here. We already know a sub n is what the answer would be. We should by now be pretty good identifying a sub 1, which is the first term. R will be that common ratio. Common ratio. N, remember, this n and this n are the same thing. Okay, they are the term number. It's the same number. So whatever that n is the same n in the exponent. And so at first, just like we did last time with sequences, arithmetic sequences, we're going to start off with sequences that where the problem actually gives you the sequence. These are obviously the easiest type because when you're given the sequence, it's really easy to identify the first term and the ratio. Now, just like arithmetic sequences, the only two pieces of information in an arithmetic sequence, the only two pieces of information you needed were the first term and the common difference. With geometric, it's similar, and I just need, I need a pen first. I just need the first term and the common ratio. Well, first term's easy when they give you the sequence, it's right there. And the common ratio is what's going on here. It looks like it's being multiplied by 2 each time. So that makes the common ratio 2. So now all we need to do is just plug everything in. So the formula is a sub n equals a sub 1, I don't know why I dotted that, a sub 1 r to the n minus 1. Remember, you don't need to worry about n when you're just writing the formula. I'm just going to do the pieces that I need, which is the first term and the r. A sub n equals the first term, which is 10. R is 2. We want to make sure we put that in parentheses, to the n minus 1. And, that's it. That's the formula right there. With arithmetic sequences, I had to do a little bit of algebra in there. This one, I don't even need to do that. You just plug it in and that's it. Now it does ask for, let me make sure here, that does ask for a sub 8. So it wants you to find the 8th term. And so remember to find the 8th term. This is the same thing you did with arithmetic sequences. I just plug it in. 10 times 2 to the 8 minus 1. You're going to need a calculator here. Definitely exponents will get a little bit high. So 8 minus 1 is 7. So I have 2 to the 7th. You want to make sure you do the exponent first. So 2 to the 7th and then times 10. A sub 8 is 1280. Okay. Pretty easy. It's pretty easy when they give you the sequence. So let's look at this one. Little bit more complicated to sort of pick out. Maybe not. Maybe you got it. But same process here. I still need the first term. So a sub 1. That's a sub 1. There you go. And the r, because we're dealing with geometric here. So first term is 6. And then the r, so we got to do a little bit here. Let's see what's going on between these. 2, so it looks like it's being divided by 3. So that ratio, remember, it's got to be multiplying by the same. You can't say that the ratio is divided by 3. So the way that you get divided by 3 as a ratio is multiplying by 1/3. So any time that you're dividing by the same number every time, it's going to be a fraction. Whatever you're dividing by every time, it'll be 1 over that. Okay, so just be careful when you're doing that, because this one's not being multiplied by the same amount, so it's not simple as just a number. Here we're dividing by 3 every time, so it's actually a ratio of 1/3, because that is dividing by 3. Okay, because the 3 is in the denominator. So I'm going to place everything in the formula. Here is the formula again. A sub n is a sub 1 times r to the n minus 1. So I'm just going to plug everything in. The only two things I need are there. So a sub n equals a sub 1 times your common ratio to the n minus 1. And then there's your formula. The next step then is to find a sub 8, which is what they asked us. So I'm going to plug this in there. So I'm going to have 8 minus 1, which is 7. So I'm going to have 1/3 to the 7th power. So you got to be careful here when you do this. Those of you with the newer operating systems can just do alpha y equals to do 1/3 to the 7th power. But those of you with the older versions of the calculator, just always keep in mind that fractions need to be in parentheses. So if you have an older calculator, you'll need to do 1 divided by 3 in parentheses and then to the 7th power. So 1 divided by 3 in parentheses to the 7th power is a really low number. Let me see. I'm getting in scientific notation here, but let me see when I then multiply by 6. Okay, so we're good. When we multiply by 6, we're okay. So a sub 8 equals 0.02. No, you're missing a 0. 0.0027, or I guess it's probably 0.00. Let me back up here. 0.003. Now, if you had used the newer operating system, if you had done 1/3 to the 7th power, it will produce a fraction for you, which is kind of nice. So this is actually 1 over 2,187. 1 over 2,187. So either answer is acceptable. If you have the newer calculator, it'll give it to you in a fraction form. The older one will give it in decimal form. Oh, I forgot. I forgot to multiply that second one by 6. That is not right. It is 2 over 729. There you go. All right. So obviously, now we're going to go to the next page. And now, as you remember from before, we're going to now start taking some things away. So instead of giving you the sequence, remember from arithmetic sequences, now you're going to be missing a piece. So if you notice in number 3 here, you're missing that common difference. No, you're missing, sorry, you're missing your first term. So I'm given a point or a term, and I'm given the common ratio, but I don't have the first term. Remember, to write a formula for a geometric sequence, you need the first term and the ratio. So your first step here is going to be to find a sub 1. Now remember how we did this last time. How we did this last time is we just used the formula and plugged in values to get us that a sub 1. So the formula, again, remember, is a sub n equals a sub 1 times r to the n minus 1. We can use the fact that they gave us a sub 4 means that n equals 4, and 12 means that a sub n equals 12. We can use that information to plug it in, and then they gave us that r is 2, and we can plug everything in. So I can plug in that a sub n is 12. I don't know a sub 1. I have a ratio of 2. That's parentheses. And then I have an n is 4 minus 1. So 4, and then all we do is solve. Okay, so 4 minus 1 is 3, 2 to the third is 8, so I end up with 12 equals a sub 1 times 8. So then I can just divide the 8 over to the other side. And it looks like a sub 1 equals 1.5. Or you could put, 3 over 2, however you want to do that, if you want a fraction form. So there's our a sub 1. Now we have everything that we need. I have the first term, and I have the common ratio. So I have everything I need. So the next step is going to be to write the formula, and that is a highlighter. Write the formula. And then I just do exactly what I just did the last time. So I'm going to take this over here so we have a little bit of room. So the formula I have, it's already right here. I'm not going to write it again. It's already right there. So I'm just going to fill everything in. So a sub n equals, remember, all you need is the first term. You could use 1.5 or 3 over 2. And I need the common difference, which is 2 to the n minus 1. Done. No algebra required after that. And now I can do step 3, which says to write the first six terms. And for that, I usually just make a table. Change colors here. N and a sub n. 1, 2, 3, 4, 5, 6. And I fill everything in. I already know the first term. The first term is 1.5. So a couple ways you could do this. You could continue plugging them in. Plug in 2, plug in 3, plug in 4, plug in 5. Or, since you know that the common ratio is 2, that just means that everything's going to be multiplied by 2 every single time. So 1.5 times 2 is 3, times 2 is 6, times 2 is 12, times 2 is 24, times 2 is 48. And you can do it that way. So the sequence would be 1.5, 3, 6, 12, 24, and 48. And that's how you'd solve it if you were missing the first term. And just like the previous notes, now we're going to finish this off with, well, what happens if we give you nothing? You have nothing. Not nothing, but you don't have either of the things that you need. I need the first term, and I need the common ratio, and I don't have either of them. So how do we figure this out? Well, just like before, we have to find that common ratio first. So we're going to do that. Find R. With common ratios, this is a little bit different than how you figured out common difference. With common difference, you were able to use these as points and then just, sort of act like they're slope, like a slope, and subtract the terms and over subtracting the term numbers to find that common difference. This one's a little bit different. So what we're going to do is almost do like we did with arithmetic means. If you remember from arithmetic means, we had a 48, and then since that's the second term, and I'm looking for the fifth, 3, 4, 5, 3, 4, 5, and I have the fifth term is 384. You're trying to find how are we getting from here to here. So you're treating this almost like arithmetic means. So how do we get from here to here? So what is that common ratio? Well, if you understand that the common ratio is the number that's being multiplied by itself every single time, you can figure out this common ratio. So if I'm going from here to here, that is a common ratio of r. Here to here is another common ratio of r, and here to here is another common ratio of r. So if we know that we're doing r and then times r and then times r, well, r times r times r times, let me make those better, times r is r to the third. So we can set this up as our first term that we have times r to the third will equal 384. Because whatever is in this first term, 48, whatever this is going to be multiplied by r times r times r. So 48 will be multiplied by r to the third to get 384. So, and then we just solve. So we're going to divide by the 48. So we get r to the third equals 384 divided by 48 is 8. And then to get rid of the cube, you cube root. Be careful when cube rooting. Make sure you use cube root and not square root, and you should get 2. A common ratio of 2. And so you can check this out and just make sure that it works. 48 times 2 is 96, times 2 is 192, and if I times 2 again, yes, I do get 384. So that's how that works to find the common ratio. That might seem a little bit confusing how the heck I got that formula. We just have to understand what's going on in the geometric sequence. So 48 is where we're starting here, and remember, common ratio is the same number being multiplied each time. So it'd be 48 times whatever that number is, times whatever that number is, times whatever that number is, or 48 times r to the third. And that'll get me 384. And then just solve. So once we have r, now the next step is, well, now we got to find the first term. So find a sub 1, and we're going to do the exact same thing we just did above. Just plug everything in now to our formula. So a sub n equals a sub 1 times r to the n minus 1, and I'm just going to plug everything in. So a sub n. Remember, I can use one of these points. I'm going to not use a really big number, so I'm going to use this number here. It's a little bit smaller. So it's telling me that the second term is 48. So that means a of n is 48, and n will be 2. Remember, this is n, and this is a sub n. Okay. I don't know a sub 1. I do now know r, which is 2, and then n, for this particular case, was 2 minus 1. So I have 2. Minus 1 is 1. 2 to the 1 power is 2. So I have 48 equaling a sub 1 times 2. And so I just divide by 2, divide by 2. That means that a sub 1 equals 24. So now I have everything that I need. I mean, I have r. I'll highlight these. I have r. Or sorry, that's not r. I have a sub 1 and I have r. So I have everything I need. So step 3 now is going to be to write formula. I took up a little bit of room, so I'm going to have to go around over here. And now I have everything I need. So here's the formula. Okay, so I'm just going to plug, remember, only thing I need are the first term in R. So A sub n is the first term times R to the n minus 1. And that is the formula. I believe that's all we needed to do. Oh, nope, it says find the 10th term. We forgot that. So 10th term, A sub 10. All these problems are the same once you get here. 10 minus 1, that's a 10. 10 minus 1 is 9. 2 to the 9th power. 2 to the 9th power. And times by 24 is a large number. A sub 10 equals 12,288. There we go. All right. Almost done. On the home stretch here. Sorry, everything's going crazy here. Okay. So a car that costs $26,500 depreciates, and its value at the end of the given year is $90,000. If its value at the end of its value of the preceding year, so how much will the car be worth after 5 years or 8 years? So here we have, it's giving us, this is an interesting situation here, because it says that the car is $26,500. So the problem with that is people will often confuse that with A sub 1. The problem is A sub 1 means that that's the answer at the end of the first term. So 26,500 was the initial cost, not after the first year. So A sub 1 would be after the first year. Otherwise, it'd be weird. You'd have A sub 2 being after the first year. It's just messy. So in math and mostly in physics, when you have an initial value here, we call that A sub 0 or A naught. You might hear that in physics, A naught. A sub 0 is going to be an initial cost, but it's not actually the number we're looking for. We need A sub 1. A sub 1 after the first year would then have to be applied that 90%. The value is 90% of what it was the previous year. So I have to multiply by 90%. So if I do 26,500 times 90%, I get 23,850, and that actually will serve as our A sub 1. It's the value of the car after the first year. Because every year after this, it will be decreasing in value. It'll be 90% of its value from the previous year. Then we have to apply that 90%. Now the ratio, since we're multiplying by 90%, would be 0.9. And so we just write the formula. A sub n equals the first term times r times n minus 1, or to the n minus 1 power. If you're a little confused by that, it's okay. Don't worry. We're definitely going to practice some of these types of problems too, where you're given a number that looks like it's the initial value, but it's really not, and you have to apply the first year to it before you can actually get to the first term. And that's the formula. So how much will the car be worth after 5 years? You would just plug 5 in. I'm not going to do the math. I think you can all plug in 5 there. And I'm just going to tell you the answer just so you can check, make sure. So after the 5th year, it is 15,647.99 if we round. That's 15,000. And that's not a sub n, that's the 5th year, so it's a sub 5. Same thing here, it should have been a sub 5. Why is this not erasing? There we go. Okay, a sub 5. And then if we wanted a sub 8, we could do a sub 8 too. Change colors. A sub 8 equals 2, 3, 8, 50 times 0.9 to the 8 minus 1. This over here should have been 5 minus 1. But again, I'm not going to work all the way through that. I'm just going to give you the answer. The answer is 11,407.38. That's a comma in there. Okay. Last piece. I apologize. These sequence lessons are just long. They just take a long time. There's a lot to them. Not enough to spread over 2 days, but it's a lot for 1 day. So I apologize. And just how I finished the arithmetic sequences, we're going to finish geometric sequences the same way by finding, instead of arithmetic means, we're going to find geometric means. Same process. You have 6. If it wants 3 geometric means, then it wants the 3 numbers that are in between those 2 numbers. This will serve as term 1, term 2, term 3, term 4, term 5. So remember how we did this before when you were trying to find the ratio. You look at the number of times. So this is the this, then this, then this, then this. This is r, then times r, then times r, then times r. So the number 6 will be multiplied times the ratio, times the ratio, times the ratio, times the ratio, or 6 times the ratio to the 4th. And that should equal 96. So when we go to solve and divide by 6, ratio to the 4th will equal 16. And then you apply the 4th power to that. And you get r is, now here's where it might be a little confusing. The 4th root of 16, technically, when we're working with real world problems here, technically the 4th root of 16 is plus or minus 2. Just like the square root of 16 was plus or minus 4. Anytime you're dealing with even roots, like square root or 4th root or 6th root or 8th root, you have a plus or minus issue. So when you do these, now when you apply the ratio to this, you're going to just do plus or minus. So when I do 6 times the ratio of plus or minus 2, it would be plus or minus 12. But notice now when I go to the third one, because positive 12 times 2 or negative 12 times, 12 times 2 and negative 12 times negative 2 are the same number, the second one won't have a plus or minus, or the next one won't have a plus or minus. And then the fourth one will. Anytime you're dealing with even roots, you have to do plus or minus, and that means that the even numbers here will also have plus or minus as well. So just something to be aware of. We'll go over it again for sure. And then the next one is 3 geometric means, so same thing between 64 and 4. So 64, 1, 2, 3, and then you're getting to 4. Here, 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 here. I have r times r times r times r, same thing. So I have 64 times r to the 4th equals 4. So then when we divide by 64, r to the 4th equals 4 divided by 64 is, that should be, I think that's 1/8. No, 1/16. 4/64 is 1/16. And so then when we do the root of that, root 4 through to that, you end up getting R equals 1, let's see, let's do 4 root of the answer. You end up getting 1/2. And it is a fourth root, it's an even root, so it's plus or minus 1/2. So when I go to do each one, I'm going to multiply by plus or minus 1/2. So I have, since this is an even term, this will be plus or minus 32, whereas this one will just be 16. And this one will be plus or minus 8, and then that one will be 4. So that's geometric means. Don't worry, if anything's a little confusing, we'll definitely go over some of this. Thanks.